It's noon. Bright sky. Then, in one instant, black. The sun is gone. No sunset, no warning. And here's the strange part. You have 5 minutes before it comes back. 5 minutes that go almost the opposite of what you'd expect, not the frozen wasteland you're picturing. And the very first second is the part everyone gets wrong. Let's start the clock. Here's the setup. The whole Earth, you, the oceans, the air, all of it, gets picked up and dropped into deep interstellar space, far from any star. 5 minutes later, you snap right back, exactly where you started. The question isn't whether you die out there. The real question is stranger than that. Would you even be able to tell it happened? Let's live it, second by second. T+0. The sun vanishes from the sky. Instantly. And that word, instantly, is the first thing people get wrong. You've heard that sunlight takes about 8 minutes to reach us. 8 minutes and 20 seconds to be exact. So people assume a ghost sun would hang there still glowing for 8 more minutes. But that's only true if the sun disappears. Here, the sun is perfectly fine. You moved. Earth is no longer sitting where that sunlight arrives. So there is no delay. One moment, bright daylight. The next, stars. And make no mistake about what just switched off. Sunlight isn't gentle. Every square meter facing the sun is hit with about 1,361 watts of power. Spread that over the whole spinning planet, and it still averages around 340 watts on every square meter of ground. It is, by far, the biggest insurance source Earth has, and it just dropped to 0. All of it. So your first clue that something is deeply wrong should be instant. Except, it isn't. You don't feel it turn off. Not for a long while. 10 seconds in, your eyes are still adjusting to the dark. And notice something. It's black, but it's not cold. Not yet. Race out and touch the wall, the pavement, the car door beside you. Still warm. That one small fact, warm, not frozen, is the whole secret of this video. And honestly, this is what we do here every time. One what if, one strict clock, lived minute by minute. If that's your thing, subscribe and stay with me. Okay, back to the clock. 30 seconds. Your brain is now screaming that you should be freezing solid. No sun means the cold of space, right? Nearly minus 270 Celsius out there. But here's the thing about heat. Earth is enormous, and it has been soaking up sunlight for 4.5 billion years. The ground, the oceans, the air, they are gigantic batteries of stored warmth. And they give that warmth back slowly. It's the exact same reason the night side of Earth doesn't freeze solid every single night, even after 12 hours of total darkness. So how slow is slow? Picture the sun's warmth staying gone for real. The average temperature wouldn't even drop below minus 18 Celsius for about a week. It would take a full year to reach minus 73. And the oceans? They'd freeze on top, but that surface ice would act like a lid, keeping the water underneath liquid for hundreds of thousands of years. A week, a year, hundreds of thousands of years. And you have been standing in the dark for 30 seconds. 1 minute. Now a new worry. If the sun's gravity is gone, is Earth flying off into nowhere? Because that gravity is exactly what holds us in orbit. Right now, Earth is moving sideways at about 30 kilometers every second. The sun's pull normally bends that motion into a smooth curve. Take the sun away, and Earth simply stops curving. It coasts in a straight line instead. But over 1 minute, at that speed, the drift off your normal path is tiny. Nothing you could feel. Nothing that breaks. And now the part most people get completely backwards. The tides. Everyone assumes the oceans would heave and swing the second the sun's grip let go. But two things stop that. One, the sun's pull on our tides is actually less than half the moon's, even though the sun is 1,000,000 times heavier. Distance wins. the sun is about 390 times farther away, and tidal pull drops off hard with distance. 2. Even if the pull did change, water is heavy and slow. Tides take hours to swing, not seconds. To an ocean, 5 minutes is nothing at all. 2 minutes. 3 minutes. And the air is still here, still breathable. This one surprises people too. You'd think the whole atmosphere would freeze and fall as snow. And it would, eventually. In the long freeze models, carbon dioxide only starts dropping out as dry ice around day 236. Oxygen only turns liquid around day 500. Day 200. Day 500. You are at minute 3. The air in your lungs hasn't even begun to notice. 4 minutes. Let's talk about where you actually are. Deep interstellar space. It's a near perfect vacuum, sitting at about minus 270 Celsius. That sounds like instant death. But a vacuum hides a secret. It's almost completely empty. There is nothing out there to press against your skin and pull the heat out of you. Cold needs contact to steal your warmth, and space has almost nothing to make contact with. It's the exact trick a thermos flask uses, so the number is terrifying, and the actual effect over 5 minutes is almost nothing. There is one real change out here. Just one. Earth normally rides inside a giant protective bubble blown by the sun, called the heliosphere. It deflects roughly 80% of the cosmic rays streaming in from the rest of the galaxy. Step outside it, and that shield switches off. For 5 minutes, a few more high-energy particles pass through you. Not enough to harm you, just enough to be the single most dramatic thing on this entire timeline, which tells you exactly how quiet this apocalypse really is. Quick one for you, drop it in the comments. What is the first thing you'd do with 5 minutes of total darkness? I'll tell you mine at the end. 4 minutes, 45 seconds. So if the planet itself is fine, what actually breaks? We do. A pilot loses the horizon. A driver loses the road. Every screen and every headlight in the world suddenly becomes the only light there is. The danger in these 5 minutes was never the physics. It was 8 billion people all meeting a black sky in the same heartbeat. The Earth takes it in stride. We are the fragile part of this story. 5 minutes. And you're back. The sun snaps into the sky right where it was. Near enough the same spot in the orbit. The oceans didn't move. The air is intact. The temperature fell by a fraction of a degree so small you'd need an instrument to find it. Physically, Earth just took a 5-minute trip to the far side of the galaxy and came home like nothing ever happened. Start the clock. Spend 5 minutes in deep space. Walk away without a scratch. That is the entire scenario. Back to reality. Could this actually happen? No. There is no known force that teleports a planet and gently sets it back. This one is pure thought experiment. But every piece of physics inside it is real, and it teaches something genuinely useful. The thing that saves you here isn't luck, it's inertia. Earth is so massive and holds so much heat that it simply cannot change fast. The same slowness that makes our climate so hard to shift in a hurry is the very thing that would carry you through 5 minutes of darkness, completely unharmed. So the honest answer to Earth vanishes for 5 minutes is the most boring, most reassuring one there is. You'd be fine. Oh, and my first move in those 5 minutes? Go outside and look straight up. You'd be seeing stars no human has ever seen, from a place we will never actually stand. Tell me yours in the comments, in 5 words or less. Next time, we don't borrow the sun for 5 minutes. we stop the Earth from spinning, and that clock is far less forgiving. See you on the next clock.